All right, so last thing we're do, I mean, we know why these didn't clean up, right? Because they run out, but let's check the thickness and let's talk about what happened. See how there it didn't cut, and on that whole inside it didn't cut, right? And then if we measure whatever thickness you're at, you're thinner than we were, right? You're at 9 thousandths. See, the reason why you're getting neck thickness variation is because you're measuring where it didn't cut and against where it did cut, and vice versa all the way around, right? So you'd have to find a spot like it cut on the inside there, but nothing on the outside there, right? So you can't really measure the thickness. I mean, maybe right there in the corner. That's what's the width of your cutters, right? Because this was too far in and this was too far this way because of the neck to body run out. That's Peterson. So same thing here. There's really no cuts that are next to each other, meaning inside and outside. It's because of all that run out that you had. Same here. I mean, we haven't cut it all in the inside. So when you're going around measuring, yeah, you're like, man, this is not cutting, you know, consistent all the way around. Yeah, because you never even cut there, right? That's 8.4. It's going to be way thick over here. 9.5. Yeah, obviously that's no good, but you never cut enough to clean up. So if we look here, $11.3, well, 10.2, oops, 9.3. So this matches with the data you posted, right? I get that, but you got to look at the reasons why. The inside never even really touched at all. So it's pretty evident why the results you were having were you were having. But if you measure our thickness that we were getting here, you know, like that piece there, you can see the cleanup difference, right? You didn't clean up. Only thing we did different is run out. Let's talk about the physics real quick. If you're spinning something and you have a stationary cutter or cutters, it's not going to make an inconsistent thickness around if you're cutting everywhere, right? It's physically impossible if your bearings are tight, which that's, you know, the IDOT, they're very precision bearings. Case fitment's good. Case holder runout's good. Everything's good, right? So when you install this, so it's just about the physics of what's happening. If you have good runout and you're taking off material that's slightly more than the amount of runout or around the same amount, it will clean up, as you can see. And if we took everything we did, you know, if we start looking at these ones that we cut of ours, right? And we start looking at the ones, let's see if I can set them here. We didn't go to any thinner than you did. We just had way less run out. So if you look there, you can see where you never even cut on all those on the inside, right? This one here, this is one you cut 3 and 3, comparing to the ones that we just cut and showed how to expand, right? So you can see the difference there. And hopefully I've explained the physics and the reasoning behind all of this.